My name is Nicolas Vanouka. I'm the Managing Director of the International Polar Foundation, and together with my colleagues, we would like to welcome you this morning for the joint conference we have organized with two of our very close partners, namely Schneider Electric and Venturi. I would like to thank both the teams of both companies and our own teams, of course, for the work, the involvement, and the availability for this morning. The aim this morning is that we wish to share some of the thoughts, some of the processes, some of the technologies that we have developed and implemented since the early days of the beginning, the opening of our Princess Elisabeth Station, Antarctica Station, the first and so far the only zero-emission station in Antarctica. What we will also do today is, together with the people, the representatives here of Schneider Electric and Venturi, also highlight some of the technologies we are developing and soon will implement in the station in Antarctica. It's therefore an honor, of course, this morning to introduce you to the speakers of this morning. To begin, Alain Hubert, founder and chairman of the International Polar Foundation. Mr. David Orgaz, president for the Benelux region of Schneider Electric. Mr. Frank Baldet, CTO of Venturi. Sarah Woti, of the Glaciology Lab of the Université Libre de Bruxelles. Mr. Preben van Overmeren, of the Faculty of Bioscience Engineering of the University of the beautiful city of Ghent. And Kate Winter, who's online, who you will see later on, is Senior Lecturer in Extreme Environments of the Northumbria University in the UK. Welcome to all, and thank you for your presence. For the program today, after the conference, we will have separate workshops on the different technologies that have been highlighted during the conference this morning now. The Venturi workshop will take place on this floor, and the the Schneider Electric and our own International Polar Foundation workshop is upstairs. You can ask all your questions, first of all, during the Q&A session, but also during the workshops. And after the workshops, you will be invited on this floor again for an informal lunch. What I have to note, indeed, is that this conference is being live streamed, recorded, so that later on it will be on our YouTube channel, which of course I invite you to visit from time to time. And to our guests online, by the way, I advise them, if they have questions, dear online participants, to post them on the chat room or to send them to events@polarfoundation.org. Before handing over to Alain, who will make the first presentation this morning, there's one important thing I would like to mention this morning. This year marks the 20th anniversary of the International Polar Foundation. Indeed, it is in 2002 that both Alain and Gigi, present this morning as well, have created what has become the leading organization in its domain, namely providing scientists, some of them here today, a platform, technology and services to do their job in the polar regions. And it's also an organization with some of the colleagues here that has set up quite a number of initiatives, and we have a lot of projects in the pipeline to make sure that the public at large understands the importance of polar research and the dynamics of the climate change. And to illustrate the 20 years of the foundation, you can see around us, well, not yet totally, we have selected a number of pictures. Should you wish to obtain one of those pictures, please go and see our team members. We're happy to help you, especially Rachel, that is at the entrance. With this, thanks again to all for your presence. And
I will start by introduce you our station in Antarctica and how we manage that and what's our project. And later on, as Nicolas said, more detail will be available with our team. So, okay. So, first of all, we are in Antarctica. You might know that it's a continent which is on the south, a surface of 14 square kilometers, million. So it's a huge continent, twice the size of the United States. And you can see that the station is on the top of the slide on the Atlantic coast. It's about 6,000 kilometers from South Africa, which is our gateway towards this continent every year. It's a place which is situated in the East Antarctic, quite a remote place. And if we build a station there, first it's because it's an isolated place. Belgium had a station a long time ago in the 50s there that they abandoned after a few years, and it was time for us to go back because science needs scientists on the field to give us data and more information about what we have to understand to improve and to make our decision makers taking the right decision. So this continent is managed by about 50 countries under a treaty, the Antarctic Treaty, which devotes this place for science and peace, and had in 1992 an environmental protocol, the Protocol of Madrid, which in fact invite all the countries member of the treaty having a station on the continent to aim for zero impact, I must say, on all their activities in Antarctica. So when we decide to go back in Antarctica and to build a station, we were driven by, first of all, aiming for a zero-emission station in the context of climate change, and I don't have time to go into details, but you might know that it's in Antarctica, and thanks to the research and especially the ice core drilling that we were able to understand that the cause of the problem that we have to face today as an anthropogenic cause. We are the cause of a problem, and we think that therefore we are also an important part of the solution. Then it's an environment through the treaty which has to be protected, and it means that when thinking of building a station, we also had to take in account the way of taking care of the environment. So the water treatment is one of the main projects on this, and after that, developing all clean technology for the field operation. And then, of course, the science support, because if we are in Antarctica, it's to support science and scientific to be able to work in Antarctica. They need a hub, they need let's say, a kind of base camp to be able to conduct their research. So, of course, we had a methodology when we studied the station, and I'm not gonna go into details with you on this now, but it was a long process. It was an engineering approach of the project, not like a drawing and then building a station just like that in Antarctica. Now we try to optimize everything. So this project started in 2004. We built the station a few years after, during the international polar years, 27, 8, and 8, 9. And since, after the first testing phase, we are trying to, every year, improving the station and also all what we do in the field, and that's what I would like to just quickly go through with you. So you can see here the station as it is now. You recognize this kind of space vessel here, which was the initial station, and then slowly all the technical facilities that we had to build, as the station was designed for 15 people, and finally now we have to welcome between 30 to 50 people. So we had to improve all the facilities to be able to conduct our mission on the terrain. So you can see here, that's the initial station. I will come back on that in a moment. And then all the facilities, which are about 1,500 square meters. So it's about 2,000 square meters for the whole station. And innovation is what we had to look to reduce the environmental impact when first we conceive and design the station, to try to limit and minimize the impact on the environment following the Madrid Protocol I was talking about at the very beginning of the presentation. Then we had to use operational experience to design innovative technical solution for reducing the global environmental impact at all stages of operation. It's why we are trying to follow. We had to, since the construction, design and build new energy models for all the new requirement that we got for supporting the science, developing new materials, technologies for the infrastructure management and also for the mobiles unit, and continue to improve the water treatment and trying to use all high-tech technology for communication, remote sensing, telemedicine as well, etc. And one of the most important thing was developing partnership with industrial partner, as we are a small organization, and we think that this is part of the success of our project, to being able to put together different big industrial partner like Schneider, who is with us today, and others, to achieve the goal that we had with this station. Then you can see that the station has this look. You can see that the main station has a tower going down in the technical space that you can see here. It's 2-level. I'm not going to go into details of that, and just explain you that as we had to develop the facilities, we used the configuration of the terrain, which allow us to have a kind of floating cantilever structure, anchor on the rock on one side, and supported by a floating basement that adjust every year, jacking all the structure to keep it horizontal. That's an innovation which allow us to develop a structure, and everything is in wood. When we look at the energy flux of this station, so in Antarctica, there are lots of wind, this katabatic wind. There are lots of sun, because during the summer, it's a season where the daily light is around us 24 hours a day, so we can use quite efficiently the solar energy. Solar thermals as well, heat exchange, passive heat. And that's the first thing that we thought about, which is having a building in wood with very few thermal bridges. And the insulation is more than 40 centimeters and 80 centimeters on the ground, which means that on this station, when we arrive after a few days, we don't have to heat the station anymore. The principle that conducted us was to put all the system, creating some heat in the center of the building, then the water places, and then all the facilities for the activities. Also, an important thing is that it's a passive building, so we have a ventilation system. We heat a little bit the fresh air coming from outside with the air which is going outside and which is a bit warmer. This is what allows us finally not having to heat the station when we are working on it. Basically, and you will be able to discuss that with our engineer later, we produce 76% of the energy with the wind. We have 9 wind turbines of 6 kilowatt peak each, and we have about 284 solar panels, PV panels, which are put around the station and in the vicinity, trying to catch the sun at different moment of the day on the most efficient manner, to be able to use immediately this energy when we need it. We also have the solar energy, and we got, of course, backup generation if we have a problem. So I guess you know what's a PV. We put that around the station. We also use bifacial PV, using the reflection of the snow to improve the efficiency of this. The wind turbine, they are not big wind turbines. They are a bit particular as the alternator is facing the wind and the propellers are changing the angle according to the speed of the wind. And we also have solar thermal panels that you can see here or here and on top of the station to heat the water for the utilization into the station. I'll come that in a minute, but the thing is that we produce the energy and we store the energy in 192 batteries. I'm not going to go into details here, but we can use a limited storage of capacity of the battery because we have a sock at 40%, so we can use 60% of what's stored in the battery to run the station. And you can see that we can't, without sun and without wind, we have a limited time to use the energy at the station, which means that this is just a slide which from last season, which shows you that it's a real zero-emission station. And the first 4 days we had to run the generator because we were doing a specific maintenance. But then during the whole season of the summer in Antarctica, 4 months, we used 1, 2, 3 times a little bit the generator. So we are not zero emission for the vehicle yet, but for the station, yes, it's really an efficient manner of managing the energy in Antarctica. How do we do that? Of course, we need inverters to convert the CD energy that we produce in AC. We need a big supervisor, which is a SCADA, put in place by Schneider, and David will explain you a little bit more about that after me. Of course, we have what we call a PLC, which is a programmable logic control to manage the energy. I'll come that to in a moment, and a virtual machine, and of course a network to be able to communicate with the station, capture the data, and send them to the scientists. Basically, it's a smart grid, which is the real innovation of this project. When we built a station 15 years ago, we used proven technology because we had to be able to build this station and to make it immediately working for the scientists. So, and the energy is produced first by the wind and the solar, as we said. It's stored in batteries, and then it's managed by the PLC under the supervision of the SCADA, and we provide the energy according to priorities. In the station, the energy is never, nowhere available for a user. You have to request it from the computer. Computer has the capacity of analyzing and measuring the current everywhere in the station. I don't know exactly how many points, but it's more than 1,000. And the user has to request the energy. If the energy is available when there are lots of wind, of sun, the batteries are full, we can get it as we used to here in Europe, for example. When we need energy, if we are connected to the grid, we can use it wherever, whenever we want. In Antarctica, it's not the case, and this is a little schema in which you can see the priorities, and that if it's important, you will get the energy. If there are less energy available, you might have to do other activities for a time, waiting for the computer to give you the authorization. And in the very beginning of the station, I must say that we had lots of problems with the users because we are not educated on using such a system. And so you know that us, when we don't get what we need immediately, we are quite angry. So we had to program with the computer what we used to call a punishment, stopping the people, and of course, when they used to come to me, I was responsible of the station, as I don't be the programmer. I had to tell them, you just have to wait, I'm sorry. And after a while, finally, everyone starts to play, the game and to try to keep the station zero emission. So I think, so that's just how it looks. The inverter in the station, I'm not going to go into detail. The SCADA is stuff like that. It's a screen with lots of interaction in which you can play with and control what's happening. And then, of course, the system has to be upgraded. The initial PLC installed by Schneider we had to go from one system to another one last season. That's part of what we have to do in a station for all the technical infrastructure. Then the water cycle is also very important. You can see that there are different steps in that. We're not going to go into detail. You have to produce the water. If you can see the loop, the easy stuff in Antarctica is that the snow. There are snow everywhere. We have lots of energy. We can easily making water. Then you use the water and you will end with gray water from the kitchen to its bathroom and stuff like that. And also what we call the black water, which comes from the toilet mainly. And then it's retreated completely with a bioreactor. And at the end of the process, part of the water, which is recycled, is reused in the system. And as we realized that it was very easy for us to produce water, we are rejecting in the environment purified water, which is in excess. So we have a little, about 1% of the water that we use with each chemical water that we have to re-evacuate, repatriate to South Africa after a while. So also on this we are doing innovation, and for example, the last season we now are able to dry the excess sludge of the system, and after a season like last year with about 3,000 man days, we end with only 45 kilo of dry matter, which is a very interesting innovation to save energy and to be, following the Madrid protocol. You can see that all the improvement that we are trying to do provide us the possibility of reducing the impact on the environment. I'm not going to go into details. And the last thing that I want to say is that this station, in fact, is running 4 months with the scientists during the season, and during the winter, like now, we don't have to be in Antarctica because we don't need fuel to run the station, and we have a satellite connection which allows us to control the station and all the parameters from a distance and from Europe. To enable scientific research and to be more efficient in the frame of the Antarctic Treaty and the Madrid Protocol, we also had to start working on the mobile unit, how to be able to more efficient on the energy production, and mobility on the terrain to open new way for research, to extend the field. We are operating on a surface of about 5 times Belgium, which means that we have lots of things to do to be able to be more efficient on an environment point of view. So the future improving that we are looking for, and I will finish with that, because this station invites us and pushes us to try to be more efficient, more and more efficient in the coming years, and especially now then the environment is now in our table, is everywhere, and we are wondering how we're going to face that. So the water treatment is one of the very important domain for us, and we are at the moment building a new facilities to be able to treat more volume, and also we try to lay the ground for recovering nutrition to be able to use that on our activities. For the field mobility, we are developing now electrical vehicle, and Venturi will tell you a little bit about that in a few minutes. We are also trying to test new wind turbines to identify how to produce more with the wind, which is one of our projects that we are looking for now. We have all the upgrade as the one for the SCADA I was telling you just before. This is part of the new technologies. It is always evolving, so we try to follow this path as well. We also want to design and build refueling for hydrogen-powered vehicles, and also looking at vertical agriculture, and this especially for one of our new projects for the 10 coming years, which is to build a new station, which is called, it's going to be called Andromeda, and opening the first University of Antarctic. A project will be a station completely autonomous on energy, with of course testing facilities for science on a technical point of view through the university as an environmental point of view. Also exploring new way of producing wind and solar energy in Antarctica to develop our activity, to have a full recycle way of management, producing food for this station which will be open the whole year long, and developing satellite activities as the location is important for that. It's all a loop, it's a project which will take us busy for the next 10 years, let's say maybe 20 years. Thank you very much.
First, thanks Alain for sharing this inspiring vision of where we're going in the next years. I think I agree with you, it will keep us busy for many years to come. So I'd like to first say a few words about Schneider Electric and then move on to our collaboration with the IPF. So Schneider is, we were a specialist in digital transformation and energy management. Right? And what we do is we help our customers to improve efficiency and also, of course, sustainability, which was very relevant for the polar station. Now, the world today is facing an existential challenge, right? So as a society, with the climate crisis, this is one of the greatest challenges I think that we are facing as a people. But yet I am, and together with Schneider, we are optimistic, because actually we are the first generation, actually, and Alain, you alluded to it, we see it in practice. We have access to all the technology and the solutions to allow us to build a sustainable future, right? And what we can do on Antarctica, we can do it, well, in Europe, in Belgium, for our world. Now, we at Schneider, we decide to play on two sides of the equation. On the one hand, well, we are a technology company. It's our mission in life to build innovation and to help our customers implement it to improve, as we said, sustainability, efficiency, and help them on their journey towards net zero, what we were able to, again, implement in the South. Now, but also on the other side of the equation, we aspire to be a role model for our peers in the industry by setting challenging ambitions for ourselves to go towards net zero, right? And because all of us together, well, for us to stay on that 1.5 degrees Celsius trajectory, well, the time to act is today, right? So as a group, so in terms of the ambitions that we set, we want to be carbon neutral in our operations by 2025, so that's in 3 years from now. We want to be net zero by 2030 in our operations. By 2040, we aim to be carbon neutral across our supply chain, that's including Scope 3 emissions. And 10 years later, we would like to be then net zero across our supply chain. Now, for that, the journey, because that started, well, 10, 20 years ago already, we've been awarded last year in 2021 by Corporate Knights as the most sustainable company in the world. So, but, well, the work is not over, that's for sure. So lots of work ahead, but we're confident. Now, so this leads us seamlessly to our collaboration with the International Polar Foundation. Look, we share common values: environmental responsibility, concern for the planet, and the belief in the absolute necessity to reduce CO2 emissions. Now, and the poles with their extreme conditions, as you already indicated, well, and their fragile balance are really important places for learning about climate change and the future of the planet. So this is why we were really delighted to be involved since the early days, since 2008, in the project as a sponsor, but also as, of course, as a historical technology partner. But Alain, I think you know the technology better than we do, because you've explained it also great. Thanks for that. Look, and our participation in this project, it's more than a sponsorship or a patronage operation. It's really a technical partnership, because it allowed us really to really test where we can go with technology available today. Because if we can do that on Antarctica in these extreme conditions, I can tell you we can apply them today in Belgium, in Europe, and everywhere, right? Now, well, it's, I think you mentioned it too, right? Working in these remote and extreme conditions, well, it pushed our engineers to overcome quite some technological challenges, but they loved it, right? I think that's so they loved the challenge. But first, as you can imagine, and as you said, Alain, ensuring smart energy management, it's existential, right? You cannot just plug in power in the socket, no sockets there, also no grid. So, and the team, so, well, we designed that together, in the end, to come to one of the first microgrids in the world, right? A smart grid, microgrid. So the energy produced by the windmills and the solar panels is stored in batteries or used immediately, as Alain indicated. Now, maintaining a balance between what is produced and consumed, again, that's critical. And again, I think, but everything that I'm saying here that is relevant for the station on Antarctica, I think we can apply that immediately also in our homes, right? We also need to, if we can maximize our self-consumption from solar power with the panels on our roof in our homes, well, we can also, so we can just apply that as is. Now, slightly bit more complex on the polar station, of course, because there in the end, over 30,000 variables were involved to manage the prioritization of every single energy request, which you explained. And of course, the architecture to make this happen, way more complex than what we need in homes, or even the most complex buildings we have here in Brussels. But yet, of course, it means if we can do it for that complex environment, we can do it, again, with us, right, or here in Belgium. Right? Now, so what we applied is it in the end the same architecture. So I said it already, it's the same architecture that we use both in industry, for our homes, for commercial buildings, for data centers. We call that EcoStructure. And at the lowest level, we use Internet of Things technology. So we ensure that every sensor and every device that has lots of data is just connected to internet and is sending the data upwards. And then you indicated, Alain, so PLCs, so just like industrial computers, are used to gather all that data. But at the end, data we know, data is telling us nothing. We need to analyze the data and help to just visualize it. That's the SCADA which you refer to in the end just allow the engineers or the people that are in front of the screens to gain new understandings, gain new insights of where energy is used, where it's wasted, and this then triggers actions to improve energy efficiency, and which is in the end a continuous improvement cycle, which I think you're growing through, right? Now, look, in conclusion, as today we are seeing also here, not just on South Pole, but also here in Europe, we see more and more occurrences of extreme weather on our doorstep, earlier than most of the models have predicted, right? So the importance of doing what we can to stick to the 1.5 degrees trajectory is more important than ever. Look, we are proud partners of the IPF, and look, we believe more than ever in this context, their mission is more important than it has ever been in the past. And today, as a society, we do have all the technology on hand to build net zero communities, not just on the small scale of the polar station, but well, across Europe. Now, cities occupy more than only 2% of the surface on Earth, but they're responsible for 70% of all emissions. So taking an action today, well, I think I would say there is no time to waste to do that, right? So I'm convinced that we can reach the objectives as set forth by the European Union and the Fit for 55 ambition by just using what has been done successfully by the Polar Foundation team and do it here in a much simpler context. So I would say no excuses and no time to waste. Thank you.
Okay. So thank you, Nicolas. Thank you, Alain. Thank you. I think without the Institute, the International Polar Foundations, and without Schneider, we couldn't have been tested the vehicle in Antarctica. And so we are very proud today to be part of the European Green Week. And all exists and has been realized thanks to one person, Gildo Pastor, that in 2000 took over the reins of the French company sports car called Venturi. And when he acquired the firm, and despite electric mobility being in its infancies, his conviction that it represented the future led him to decide to specialize in high-performance electric vehicles. Venturi created 6 concept cars. On the other hand, we've been official suppliers of motors, electric motors for electric versions of the Citroën Berlingot, aimed at the general public and the French postal service. In 2015, Venturi was once again selected to supply electric motors. In addition to being the first team to commit to the Formula E, so that's the electric sports car championship, Venturi was also one of the championship official constructor from 2015 till 2019. Since 2009, we are also focused on completing our global challenges, which are technological and human missions aimed at demonstrating the efficiency and durability of electric vehicles. We developed 3 machines. The Venturi Buckeye Bullet 3, done with Ohio University in America, which currently holds the world speed records for an electric vehicles, 549 kilometers per hour. We also did a motorbike, the Vauxhall Wattman, which is the world's fastest electric motorcycle. We reached 470 kilometers top speed, and the official speed, which is the average of speed on 2 runs, is 456 kilometers per hour. The motorbike was ride by Max Biaggi. And then, obviously, we will discuss more in detail the Antarctica project, our electric polar exploration vehicle. So in 2009, through the Princess Albert II Foundations, Venturi was entrusted with the task of providing a zero-emission solutions that would enable access to areas of scientific study in Antarctic. 12 years ago, there was no technology that allowed such a vehicle to operate on a rough terrain at very low temperature. Nevertheless, the work started with a laboratory, a demonstrator vehicles, we call it Antarctica 1, and then with the development of the second versions, that is the one you can see on the screen. From these 2 first experiences, we developed a third version, the one that now stay in the station. And so we've been there in December 2021, which was very helpful to develop and finalize the vehicle, meaning that teams at the zero-emission base have access to an eco-friendly mode of transport for their scientific missions. This is a world first. Never before has an electric vehicle with caterpillar tracks operated in Antarctica. The Venturi Antarctica brings together all of the Venturi's technology expertise. So from all our projects, we put everything inside these vehicles. Our research and development teams already working on world speed records for Vauxhall and Venturi, design and manufacture the vehicle unlike any others. It can carry 1 to 6 people, equipment, and even a second battery pack to extend its range. Autonomy is between 50 kilometers up to 100 kilometers. Obviously, it's snow dependent. It can work at very low temperature, minus 50 degrees C. We use aerospace technology for the cabin insulations. The tracks, the caterpillar tracks, have been developed with Michelin Camso. It's a special development done for these vehicles that could work down to minus 50 degrees C. And we had on top solar panels that can eventually recharge the battery, but it would take ages. But it helps to have the, let's say, the auxiliary needs for the vehicles. We also had some cameras to have a nice, clear view around the vehicles, because those kinds of vehicles can be dangerous when they are driven. It's not as a car. It's easy, but not as a car. So during its first week of operations, the Antarctica has enabled several scientific missions to be carried out on the ground, including maintenance work on several automated weather observation stations and the new Belgian atmospheric observation stations located at an altitude of 2,300 meters. Thanks to this new type of vehicles, it was possible to reach the stations without disrupting the environment. All these journeys also provided an opportunity to take density of snow, temperatures, and which are used to validate satellite measurements. In addition, these new versions of the Venturi Antarctica enabled a simulated emergency rescue to be carried out. I think it was not so easy, but we managed, based on the scenario of extracting someone from the bottom of a crevasse. So let's take, I think all my words will be emphasized with a nice video that can show what the vehicle is capable of.
Ce véhicule représente un espoir pour le futur. C'est un véhicule plein de promesses. La promesse d'une vraie mobilité propre.
Thank you, Mr. Baldet. Indeed, some more questions can be asked about the vehicle during the workshops. And I would like to ask Sarah Wouty to come on stage for your presentation. Sarah?
I'm a glaciologist working at the Université Libre de Bruxelles, and I'm working on reconstructing the accumulation history in a coastal region at approximately 200 kilometers from the Belgian station. So I use ice cores, and I went 2 times in Antarctica. The first one was 3 years ago, and I went back this season. And since I'm working on ice cores, I have to be in the fields where we live in equipped containers that have many solar panels, as you can see here on the walls, and they provide us the energy we need to melt snow. That is really important for cooking, to charge many of our devices. You can see also we have some solar panels on the roof. And these solar panels are really useful, but unfortunately they're not always enough to provide the power we need. For example, when we face some days of bad weather, which we encountered a few times this season. And also the power demand is quite important. We do ice core drilling, as you can see here. So we use still a bit of generators, and we are not completely zero emission in the field, so there is room for improvement. But when you see all this presentation before, I have no doubt that it will get better, and that's an exciting challenge for them, I guess. So what I would like to say is that I could really witness this will to improve in 3 years apart. We can see that there is more energy that is produced by the solar panels and the windmills. They have better batteries for energy storage, and as we said, there is these electric vehicles that are tested. I had myself the chance to try and drive the Venturi vehicle. It went quite well. And to me, I'm really impressed by this monitoring of power demand that Alain has been presenting, and this implementation of the smart grid that allows the energy used to be optimized according to the reservoir and the energy that is stored. And at the station and in the field, you really realize that it's important to be aware of your energy use, and you make some good habits that you take back home, which is really, really nice. And I just, would like to conclude by the fact that it's fantastic as a scientist, but also as a citizen, to see that it's possible to do research in a zero-emission station, but also to live in a zero-emission station that is located in such a harsh polar environment. And you really want to see more of these initiatives in Belgium. Thank you.
My name is Preben, and I work as a PhD student at Ghent University, mainly on how anthropogenic emissions from the southern hemisphere end up in Antarctica as particles or as gases, and if they are gases, how they are transformed to particles and how they interact with climate on Antarctica by radiative scattering, but also as cloud formation particles. So I had the opportunity to go to the station 4 times already, which in itself is quite unique. But the fact that it is a zero-emission base is really advantageous for us because, we get all this clean energy, and if you want to measure gases which are present in really low concentrations, yes, you can imagine that it would be quite hard if there is a generator running just like 50 meters away. So the results we obtained are only possible at this station, and I can say they are really unique, so thanks a lot for that already. Another project, a big project we have been working on, is building the remote atmospheric observatory. This is the test setup close to the station before we deployed it, and there are a few instruments which are monitoring the atmosphere, like a weather station, but also like trace gases and aerosols. And these instruments are running year-long autonomously, so they're modified for it or specially developed for it, and powered only by wind and solar energy, and there is also a battery storage. So here you can see it in place on the Antarctic plateau. And I think this is quite unique and also shows something very interesting, that renewable energy can be a solution instead of a hassle, because people often associate it with extra effort. But this wouldn't have been possible with just a generator. So this is something we really learned a lot from. Then the Venturi. So going in the field is, still, we have to rely on some combustion engines still. But then with this year, we could try the Venturi and go to the atmospheric observatory there without leaving an impact. And I thought this was really cool and shows a lot of potential. So in that case, the future is bright orange in this case. Also, thanks for saving me out of the crevasse. It wasn't the bottom, it was only half of the crevasse. I just want to conclude with saying that as a scientist, actually, we should also be a little bit self-critical and think of the environmental impact we have while doing science. We should also set an example and do better than just best practices. And it is initiatives like the station and Venturi which help us to shift this balance in our favor. So that's really important to continue doing science on the continent. So thanks a lot.
I'm in the UK today, and I thought it would be wrong of me to fly to Belgium to talk about zero emissions. So that's why I'm presenting online to you today. I didn't have time to take the Eurostar. So my name is Kate Winter, and I'm a lecturer at Northumbria University in the UK. And I went to the Princess Elisabeth Station in 2018-2019, the season, and 2020, funded by Fonds Tour, and I loved it there. So a quick introduction to the research that I do when I'm there. I'm interested in how glaciers move sediment, which is rich in nutrients like iron, towards the Southern Ocean. And for that, I use a technique called ice penetrating radar. And I'm also interested in how much sediment is coming off the mountains and when. So both of these methods are quite battery intensive. So if we click the next slide, we'll see a photo of that. So this is my radar system here. So I pull the radar up along the ice sheet. And I would love to be in a nice warm Venturi for this, because it's quite cold on a traditional snowmobile. And the radar is being pulled behind me. You see it here on the right, all the equipment that I need to take with me to run my radar. So it's wonderful that that comes off zero emission energy, and I'm not, destroying the environment while trying to survey it. So we look at my next slide. The next technique that I use is seismic monitoring of the mountains. So I put this little tiny seismometer on the mountains, but it needs power all the way through. And just like Preben said, it's a solution. There's no way I could put a generator up on the mountain here. It wouldn't be safe. There's lots of bird colonies here. I wouldn't want to put a generator up there. So the team at IPF here on the left are helping me to install a big solar panel up there. And it's wonderful being at the station where there's experts in this. I am not an expert in solar panels. I'm an expert in glaciology. So it's fantastic to be with people on the ground who know what they're doing and can help me get the solar panels up. So we click on the next slide. That's the kind of science I'm doing, and others have touched on what it's like to live at a zero emission research station. But I'd like to give you my personal opinion of it. I think what Sarah said about you kind of learning to adapt to a new rhythm, and Alain mentioned this too, kind of coming back to that living with the weather. And here we see, this is a very simple chart. All that complicated science and engineering that goes into running the zero emission station boils down to a chart with a pin here on the left. And the pin tells us that on this particular day, there was lots of water. So the snow was caught into the snow melter, and there's enough power from the solar thermal for us to have a nice shower. It's okay. But actually, it was maybe quite a cloudy day. Maybe there wasn't very much wind. So the power supply wasn't great. It was on orange. So we just have to be more mindful of our power use that day, knowing that the next day we'll have lots of power. So if we click on the next slide, I'll show you an example of a good power day at Princess Elisabeth. When the wind is howling and we can't go out to do our science, that's a great washing day. So these bags here are wash bags from the station staff and the scientists. And it's one of my favourite photos from Princess Elisabeth, because everybody came on the windy day with their washing, knowing this is time to do the washing. We're so in tune with the nature. We know not to bring our washing up if it's cloudy and there's no wind because the washing won't get done. And it seems a luxury getting your washing in Antarctica, but we really don't want to go back to those old days being this really smelly polar scientist. So I've got one more slide to show you, and it is looking at the outreach that I do as well. So I'm a scientist and I do a lot of scientific outreach, and I teach people about geology and about ice. But I'm also passionate about the zero-emission philosophy of the station, and I teach that in classrooms too. So this is a picture of me in a local primary school. Now, I've not had permission to share this photo specifically for this event, so that's why the children have smiley faces on. But if I took those little smiley faces off, you could see these huge smiles. They're so excited because in this workshop, we designed solar panel wind turbine blades. And each group of students designed different blades. And then we tried it out in a voltmeter using our fan to simulate the wind. And this was the winning team. And they're clapping and they're so excited because they designed their own wind turbine. And they were inspired by the wind turbines at Princess Elisabeth. They now know how to generate their own energy. And they can see that when they walk down, and we see in the UK, there's lots of wind turbines. You know, it's quite a windy place like it is in Belgium. And they can relate to that engineering philosophy at home. So I think what we're doing in Antarctica is so important. And I think it has to be shared with the world. And the world is very open to this new technology. And I'm super excited with, all the innovations that are coming to the Polar Foundation. And I hope that I can get to visit again soon. Thank you very much.
Can you please rephrase your first question again, please?
Okay, sorry. Well, our wind turbine are coming from Scotland, and this company now has been bought by Superwind, is it? SD Wind, which is a Japanese, I think, company. So it's a 9 meters high wind turbine, and with the alternator facing the wind, as I said during the presentation, and it's the 6 kilowatt peak. So we have 9 wind turbines of this kind. And in the beginning, we had a problem after the first year, and so we had to improve it. And since, I must say that we don't have any problem with this wind turbine. We have the annual maintenance, which is quite easy and can be done in a few days. So that's a good solution for a station in Antarctica because it's easy maintenance and it's then not expensive.
Third question, is any of this applicable in India?
Yeah, definitely. The thing is that you need willingness to do that, and I think that it's one of the, it's slowing down the innovation in the Arctic. We participate to a project to suggest for all the Arctic station another kind of management of the energy, and one of the, I was not responsible of that. It's people at the foundation, but one of the answer that we got from these people was that yes, but we don't have the money to go for it. So I think that might be one of the biggest problem to face. But of course, as David said as well, the technology is available nowadays to really go ahead and completely improving the way we are managing a station first and gradually working in the field.
It's a good question. The autonomy is key. But it all comes from the specifications we had from the beginning. The first vehicles, when we work with the French Paul-Émile Victor, the French stations, they ask us for only a 15 kilometers range of autonomy. But when we tested the first prototype, we immediately saw the difficulty that only having 15 kilometers is very low. So we push the boundaries, the limits up to 50 kilometers. It looks not a lot, but at the end, when we tested the vehicle in Monaco just before, because we did it very rapidly, and when we are on the normal road, we can go up to 100 kilometers. The difficulty is very linked to the snow. The more you go deep in the snow, the more the consumptions increase. And the second difficulty was the need to have tracks. Caterpillar tracks is requesting a lot of energy consumption, so the design is not optimized for autonomy. But we try to do our best to, obviously it's all about efficiency between the electric motors to the gearbox, the reducer, down to the tracks. We work a lot with CAMSO to minimize the consumptions. So we have a very flexible track. We also design the suspensions to have the best ground contact. Nonetheless, when we did the first test, the target of 50 kilometers was not enough, and so that's why when we sent the vehicle, just before sending the vehicles to the stations, we had a second battery pack on the rear. So today we have 2 battery packs, and this is one of the challenges, because the energy we have in the vehicle is a bit less of 100 kilowatt hours. So it's 1/4 of the battery of the stations. So this gives also the challenge to recharge an electric vehicles, and you will have to update the charts, adding a link on the smart grid going directly to the vehicle, because we have to ask the permissions to recharge the vehicle. And to improve the autonomy, we are thinking of okay, we can change the battery pack going to solid-state battery packs, even if solid-state battery packs are not designed for very low temperature. But looking, thanks to the scientific missions and also to the maintenance of the stations, there is an image where we pulled a sled. And the idea now is to design a new sled full of battery pack to increase the autonomy. And in this way, we could carry a lot of materials or add a cabin, but just at the under chassis, full of battery packs, we can increase the range of the vehicle. So we are now studying this new add-on for these vehicles. The vehicle is very flexible. We can change it. We can add scientific instruments, but we can also pull sleds. And this is very important for the future of this vehicle.
If I can add something, I mean, you need a beginning to everything. And so now we made a first step with the station. We are heading for a new station as well. But vehicles in Antarctica are critical for science. And there are 2 kinds of mission on the terrain. You've seen and that when you have a station, you can operate in a distance up to 200, 300, 500, 600 kilometers from the station. But most of the activities are in a circle of about 50, 60 kilometers around the station, which means that an electrical vehicle is really the future of science in Antarctica, especially because we can gather more energy in Antarctic than in the Arctic, and especially as well thanks to the katabatic wind, which are not really existing in the Arctic. So we have the capacity, and when they came with their vehicle, we were a little bit stressed because, of course, the station is working now as a zero-emissions station, but would we really be capable of recharging this little toy they came in? And in fact, yes. So that means that they are really a future for this kind of vehicle, and the range has to be around 100 kilometers. We also use, as you saw, skidoo. That's electrical skidoo are coming slowly. So with this electrical vehicles, these 2 kinds will be able to be much more performant in Antarctica, and maybe in a later stage, those kinds of vehicles will be used by other stations. But for long distance, that's going to take more than 10 years. we are not we're not going to be able, I think so, capable to do that with batteries. Maybe hydrogen will bring a solution in the future, but we are not at all yet there.
And Frank, if I may add as well, the exercise of improving the vehicle is not only a theoretical one or one that happens in Monaco, but your teams will also come in the coming years to the station to implement and test it. I think that's important to note as well. Any other questions? If not, I invite all of you to move around. I mean, here again, the Venturi workshop will take place on this floor, here at the stage. And the IPF, the International Polar Foundation workshop, and the Schneider Electric workshop will be taking place on the upper floor. So I invite everyone to move around, maybe to see the 3 workshops, and then we'll have an informal lunch. In any way, thank you very much. If you have any other question, please approach any of our team members. Thank you very much.